Okay, I believe now the audio is working fine. So what I was saying is vectors, as we know, is a physical quantity which has both magnitude as well as direction. And the vectors are represented by. Okay, I believe now so what I was saying is vectors, as we know, is a physical. So basically, the length signifies what? Length signifies the magnitude, and the arrowhead signifies the direction. And we learned basic operations on vectors. So first was we learned that you can add two vectors, you can subtract two vectors, you can multiply, and so these are the operations which we learned on vectors. Now, just a moment, guys. Okay, so yeah, so I was looking for the specific input, so that because it becomes otherwise a whole lot of exercise to go through every concept. So is vector addition or is operations on vectors difficult, or they were talking about components and resolution of vectors and things like that. But never mind. Let me just recap whatever we learned in vectors. So we learned negation of a vector or a negative of a vector. So negative of a vector Before that, you need to understand how vectors are represented. So basically, we have points A and B. So A being the origin, B being the destination. I'll be a little fast here because we are doing a recap, because we want to get into the 2D motion first. So hence, so vector AB is denoted by the origin and the destination and an arrow over it. And the magnitude of AB is given by this representation, right? So vectors, this is how a vector is represented. There are multiple ways of representing a vector. Many times the vectors can be represented by the magnitude itself and a arrow put over it. So this is a vector A. Yeah, so hence we want to quantify the direction also. Yeah, length is finding the magnitude is not a big deal, but how do we quantify vectors? And for that we need to understand basic operations on vectors and what are unit vectors and things like that. So what is the negative of a vector? Negative of a vector is nothing but a vector, for example, if this is vector AB, then this is negative AB, right? So let's say CD. Okay, so we say that AB vector is equal to negative DC, or you have to write, so origin to the end. Yeah, negative DC. This is what is negative of a vector. Now, what is the unit vector? Unit vector was, what's a unit vector? Unit vector is a vector with magnitude 1, magnitude value 1. Okay, in any particular direction. So hence why, and then you see unit vectors are a very beautiful concept to quantify direction. Used to, let's say now we'll quantify directions as well. Quantify direction, because in this vector what is happening, the magnitude is 1. That means the direction, you can just affix this to any particular direction and you'll get a vector in that particular direction. So that's what unit vectors help us in. Now, if you remember, we then went on to doing some operations on vectors. So first operation was, let's say we are doing addition of vectors. What does it mean? Addition of vectors. What does addition of vectors mean? So let's say you have, and then here we learned two basically. First was triangle law of vector addition. And we also learned parallelogram law of vector addition. So we will see both. And we'll just, I'm not going to derive the relationships because it will take time. We will here only revise the concept. So let's say if vector A is here and vector B is this, and we are trying to find out what is meant by A plus B, and let me call this as C. So we are finding a vector C such that A plus B equals C. What does it signify and what does it mean basically in vector notation? So we what did we do? We simply translated B onto A. So this is how we did. So let's say this is A, and let us say that, okay, first of all, transfer the tail of B onto the head of A, and then simply join the tail of A to head of B. Okay, let me name this. So let's say this is A, B, and this is C. Let's say this was vector A, this is vector B, and this is vector C. That's what triangle law of vector addition says, that if you have two vectors such that the tail of one lies on the head of the other, then, or the tail of the second lies on the head of the first, then the vector joining the tail of the first and the head of the second signifies the sum of the vectors, right? And let's say this particular vector B was making an angle theta with positive x-axis. Let's say if my, or with the direction of A. Let's say this is the direction of A, line of action. This particular thing is called line of action of A, line of action. So let's say, and we say that counterclockwise direction is positive. So counterclockwise direction is positive. Okay, so this line of action. So let's say vector B makes an angle theta with line of action of A, then we know that, what do we know? We know that magnitude of C, that is the resultant vector's magnitude, is given by under root magnitude of A square plus magnitude of B square plus twice of magnitude of A, twice of n magnitude of B times cos of theta. And the direction, let's say the direction is given by, so what is the direction C is making with respect to A? Let's say this angle is alpha. Then we know tan of alpha was given by B magnitude of B sine theta upon magnitude of A plus magnitude of B cos theta. Yeah, these are the two relationships for triangle law. Now, parallelogram was nothing but very similar to triangle. So, in the concept is, and the concept behind that is, we can parallelly transfer. So, vectors. So, the concept is, what is the concept? Vectors can be transferred in space. Parallelly without having any change in its impact, but for rotation. Yeah. So if you shift any vector in space parallelly, it will have the same impact, but the impact on rotation only changes. So that, barring that, everything remains same. So hence, what we can say is, let's say if this was vector A and this was my vector B after shifting parallelly so that the tails and the head coincide. So by triangle law, we got the resultant like that. This was vector C. Same thing can be said like that. Let's say if B was instead shifted over here, and then you complete the parallelogram like that, then also the diagonal, the principal this diagonal, this diagonal. So let's say this is point A, B, and C. and this is D. So basically this is also vector B, because vector B was parallelly shifted to AD. So no impact. Hence, and we can say that either you follow triangle law, where you say that the tail of the second one is coinciding with the head of the first one and join the third side, giving you the vector sum, or you take this thing, where complete the parallelogram and the principal diagonal will give you the vector sum. Okay, and so hence in terms of the expressions, nothing changes in this case. Also, if you say this is theta, or angle between two vectors is theta, like that, and you get the same two expressions here for magnitude as well as the direction. Now, one thing which I got to know, that you wanted to understand resolution of vectors. So if you see, this is what is summing the vectors, right? Sum of vectors is clear. So you know sum of vectors. Now the opposite of it, or the, if you can sum a vector, you can actually distribute a vector into two parts, or break the vectors into two parts. And here is what is called resolution of vector. Resolution of vectors. So you can resolve a particular vector in multiple vectors, meaning what? You can express a vector as a sum of multiple vectors. Like, let's say if this is one vector, this is another one, and let's say this is the third one. So A plus B plus C is equal to D, right? So A plus B plus C. So we say that D is equal to A plus B plus C. So we say that sum of A plus B plus C is D, and on the other side we can say components of D are A plus B plus C. Now you can clearly understand there could be million ways how we can express one particular vector as sum of multiple vectors. For example, the same example, if you can do this as well. So these are multiple vectors whose sum again will be D. Another example could be, let's say this vector and then this vector and then finally this. So D can be expressed as multiple such vectors, sum of multiple vectors. So, but then in our in physics literature, or for the ease of purpose, we resolve vectors along the coordinate axis. So what do I mean? So let's say this is my x and this is y axis. So we resolve vectors in coordinate axis, along coordinate axis. So let's say this is a random vector here. Let's say this is A, and it is making an angle theta with x-axis. Okay, now what we can do is, if you see the same vector, if you drop a perpendicular from here onto the x-axis, let's say this is point A, this is point B. So you drop a perpendicular from B onto x-axis and call it C. So don't you think that we can express A vector A as let's say this vector AC plus vector CB. So hence I can say vector A is, and let me put a nomenclature. Let's say this magnitude, I'm saying this vector, I'm saying AY, vector AY, and this is, let's say, AX. X and Y are the subscripts. X and Y represent the direction along which they are aligned. So let's say A can be very well written as AX plus AY. Okay, now what do we know? Magnitude of AX, magnitude of this vector is AX, and magnitude of AY is AY. Okay, now let us imagine that there is a unit vector along x-axis, right? Let this unit vector be called I. So what is I? So I is unit vector I cap, we say unit vector along x-axis. So magnitude of I is how much? Clearly 1. So hence, and also understand, let's say this vector also is unit vector along y, and let's call it as j cap. So what is j cap? J cap is unit vector unit vector along y-axis. So now, if you think carefully, if you see carefully, can I not say that ax vector ax is nothing but ax times I vector I cap, and ay is ay times j. So hence, by triangle law of vector addition, I can say that a vector a is axi plus ay j. Right now, the idea is to find out the value ax and ay. Now you'll use trigonometry here. So if you see in triangle ABC, sine of theta is equal to ay upon a, yeah, perpendicular by hypotenuse or opposite side by hypotenuse. So hence I can say ay is a sine theta. Yeah. Similarly, if you see cos theta is ax upon a, so this implies ax will be equal to a cos of theta. Correct. So what do we get now? So if you come club what all? Let's say this is 1, from 1, from 2 and 3. From all these threes, what can we say? We can say that vector A is a sine theta I. I'm sorry, a cos theta I. Wait, yeah. So I can say this is a cos theta I plus a sine theta j. So if you can see, I broke down vector A in terms of its magnitude and its direction, and I have broken down or resolved is the proper term. So I have resolved the vector A in two direction, x and y, like that. So this particular thing is called x component of vector. X component. Why? Because it is aligned towards x axis. And this particular is called y component. Y component. Let's take an example and understand. For example, let's say, okay, so I will use okay, let me use the coordinate system. Yeah. So let's say this is my coordinate system. Okay. And here is this is x, and this is y. So what do? Let's say I have a vector like that. Yeah, or I'll pick up a full arrow. Let's say we have a vector like that. Okay, and I want to resolve this vector into two components. So what would I do? So if you see, this is how you'll resolve it. So this is my x component, and yeah, and this will be my y component. Sorry, y component will be this much. Okay, so if you see, this is a, this is a, this is a, this is ax, sorry, this is ay, this is ay, this is ay, and this is ax. And let's say this angle is theta. Now let's say a was, magnitude of a is given as 10. Magnitude of a is given as 10, and let's say theta is 30 degrees. So how do we resolve ax, and what will be ay now? So ay is clearly a sine 30. We did the calculations above, and ax is how much? A cos of 30 degrees, isn't it? Now, so hence it will be a into sine 30 is half. Yeah, so it is 5, and here it is 10 into cos 30 is root 3 upon 2. So it is 5 root 3. So we say vector A is x component will be 5 root 3 I plus 5 j. This is how you resolve, right? So a quick tip about resolution is the side opposite to theta is the sine component, and side along theta is x component. If you can see, this is the side along theta, right? This is, or let's say this is side containing theta. This is side containing theta. So hence it will be a cos component. This side is opposite to theta, so it will be sine component, opposite to theta. So sine component. Now, where do we use all this? It will be used, a lot in, let's say, projectile motion, or let's say when you do Newton's laws and we draw free body diagrams. So let me take a practical example and make you understand how this works. Okay, so let us take a case. The case is this, that we have, let me say, we have a inclined plane. Okay, let's say this is, yeah, we have a plane like that, inclined plane. So, and let me say, yeah, the plane is something like that. Okay, this is a wedge, and let's say there is a small block kept over it. This is a block. So let's say there is a block kept over it. Yeah, block kept on a frictionless surface. And let us say this angle is 60 degrees. Okay, this angle is 60 degrees. Now, basically, if you remember, we used to draw a free body diagram. So what all forces, let's say this surface is frictionless. So there is no friction acting on it. Now, what all forces are acting on this block? Let's say the block had a mass. This mass is m. So let me write here. So let's say this is m. So hence one was the, so what all forces are acting on it? So this is mg. Okay, and then there is no friction. So what else? There will be a normal force acting on it from normal force is acting like, yeah, and there's no friction. So only two forces. One is the mass, the weight mg, and the normal force. Yeah, there is no other force acting on it. So hence, to write the Newton's laws for this, what did we do? We identify, or let's say determine our x and y axis. So it's always a good practice to take along the incline as an x and along perpendicular to the incline as y axis. So this is my reference coordinate system. Now I have to resolve all the forces in x and y. Now clearly normal is in y direction. So we don't need to resolve normal, but clearly the weight mg is not along the two coordinates axis. So we need to resolve that. So what do? We resolve into two components. So what will be those two components? So these are the two components. So this is the first y component, and this will be my x component. Okay, and how do we resolve that? So let's say if this is 60 degrees, or let's say this theta was 60 degrees. So if this is theta, this angle is 90 minus theta. So hence this angle has to be theta. So now if I draw it separately, let's say this is the point object. Now I'm considering the center of mass, and this is my mg. This was my normal. Okay, and this was the incline, and this was 90 minus theta, and we said that this is theta. Okay, so hence this component of mg, as I told you, there are two components. What all? Let me use a different color. So this is my y component, and this is my x component, y along y and along x. Okay, though they are negative y and negative x, but they are aligned towards the y-axis and x-axis. Okay, now, so what will be this? This particular side carries theta, contains theta, so this will be nothing but the component will be mg and then cos of theta, and the other component, this one will be nothing but mg sine of theta, because it was opposite to theta, so I can just now neglect this vector. So hence we resolved the vector mg into two components, mg sine theta and mg cos theta. And since your x and y was like this, so this was, you defined this as x and y, so you can write in this vector weight mg, weight and or the weight acting, let's say if I use term w, weight is nothing but mg cos of theta minus I. Why minus I? Because it is in the negative x direction. So this is positive, so this one is negative x, right? So negative I, and mg sine theta negative j. This is how. So hence we used resolution of vectors to resolve weight vector into two components, one along the inclined plane and one along the, or perpendicular to the inclined. This is where resolution is used. Now there are multiple other areas, as you have already seen, where vector resolution is used. Now another thing, important thing which you need to know is, let's say if a particular vector A is given as axi plus ayj, where ax and ay are plain scalar quantities, I and j are unit vectors, and a being a vector. So hence we say that magnitude of A is nothing but under root ax square plus ay square. And you can easily prove this also. So how? So this is my A, this is my ay, this is my ax. So you know a square is equal to ax square plus ay square. How? By Pythagoras theorem. Right? So you now know if the components are given, you can find out the, if the components are given, you can find out the vector magnitude. You can also find out the direction. How? So let's say this A is making theta with x-axis. So what do we say? We can easily say tan theta. Tan theta is ay upon ax. Hence theta will be how much? Theta will be tan inverse ay upon ax. So if the components are given, we can find out both direction as well as magnitude. Let's take an example. So let's say we have vector A as 3i plus 4j. So magnitude of A will be nothing but what? Under root ax square, which is 3 square, ay square, which is 4 square. Hence it is nothing but under root 25, which is 5. Okay. Now if you see all the vectors which are like either A is 3i plus 4j, or minus 3i plus 4j, or 3i minus 4j, or minus 3i minus 4j. In all the cases, if you see, the magnitude remains the same. Yeah, but the direction will keep on changing because of the these are three different vectors. So for example, this vector is in the first quadrant. This one is in the second quadrant. This one is in second quadrant. This one is in the fourth quadrant, and this one is in third quadrant. If you see carefully. Yeah, so this is what is, how do we find out the magnitude of a vector if the components are given, and the direction as well. So direction will be tan. So let's say this vector make what angle does this vector make with x-axis? Nothing but, let's say that angle is theta. So tan theta is given by 4 upon 3. But in different cases, in this case it will be 4 upon minus 3. Here it will be minus 4 upon 3. It is minus 4 by minus 3. So hence you will get different directions as well. So this tan theta is 4/3. So theta is equal to tan inverse 4/3. 4/3. Okay, and which I believe is yeah. So this is how you find out the angle and the magnitude. Yeah. Now this particular information will be used a lot in, let's say, motion in 2D, and that was what was a topic of discussion today. So hence this is the primer or the prerequisite. You must know how to resolve a vector, how to find components of a vector along two different directions, and now we will take up the study of. So I'm skipping all the other parts of vector algebra, like multiplication of vectors and dot product, cross product, and how to find out angles between them. We might take this up in a different class, but today let's focus on the subject matter, and that is motion in 2D. So the prerequisites are done. Motion in 2D, 2D. What does it mean? And how is it different from a motion into 1D? In motion in 1D, see, again, we'll see, we know that motion is relative. So we'll keep coming back to our reference frame. So let's say if you are, let me draw a reference frame first of all. So let me say that, yeah, so this is my reference frame. Okay. And what am I saying? I am saying this is my y-axis. And this is my x-axis. Okay, so motion in 1D will be nothing but, let's say, if the direction of the motion stays constant, then we normally say that it is motion in one direction. For example, if a body is moving along this line only and it is not deviating from its path, then we say motion in 1D. So what is 1D before we get into motion in 2D? 1D is when the object travels in one particular direction, whatever it is, one particular direction, right? So then we say that this is called motion in 1D. Or in other words, you can say that when the y and x coordinates or position coordinates, or basically I'm referring to the position, right? When the y and x coordinates of the object vary linearly, then we say that the body is undergoing 1D motion. Okay, very linear. So basically, if you find out the x and y coordinates, they will be nothing but they will form a line. So then we say that the body is undergoing 1D direction, right? If in all other cases, let's say, then it is not 1D direction. And specifically, what is 2D? 2D is when a body which we have already known, we have to consider it to be a point mass, right? So we consider that the entire mass is centered at the center of mass, and there is no dimension of the body itself. So when a body undergoes motion in a plane, which is not linear. Because linear motion also happens in a plane. So, but when a body is a point mass, that is, undergoes a motion in a plane which is not linear, it will be called a 2D motion, two-dimension motion. So if you see, and the x and y coordinates never vary linearly, they will have any relation but linear. So for example, a best example is the projectile motion. So let's say if you throw a projectile or a ball or a stone in such a way that it is thrown in at an angle from the horizontal, then it will take a path which is not linear, and hence we say this is an example of 2D motion. 2D motion, right? Similarly, let's say a satellite is going around a planet, and though in actual sense it's not a 2D, it's actually a 3D motion, because it's not happening only in one plane. But just consider a hypothetical case where there is a planet and there is a satellite which is circling around the planet. Then it is a case of 2D motion. So circular motion are again 2D motion, right? But we have to be very clear that there is no movement of the satellite beyond one plane. So 2D motion means you have to have one plane, and motion must not be linear, right? So then it is called a 2D motion. Okay, now let us understand how things will, or let's say what are the kinematics parameters which we studied for 1D motion. Let's say things like position vector. So what did we learn in kinematics? First is position vector. Position vector will be there. Then there will be something called velocity vector. Velocity will be there, right? Which was nothing but rate of change of position vector, rate of change of position. And then there was something called acceleration, and acceleration was rate of change of velocity. How would the analysis from 1D differ? So in 1D, we used to say that, or we used to take only one direction, and there were three basic equations were there. What three basic equations were there? First was velocity vector v is equal to initial velocity plus acceleration times time. This was the first kinematic equation. Then we had displacement s is equal to initial velocity times t plus half into a t square. If you notice, now I am putting all the equations in vectors, and and third one was v square, or rather v square is equal to u square plus twice a s. Yeah, these are all. So basically what's happening, these are all dot products here. Yeah. So if you see, these are the vector equations now I'm using. If there was no mention of 2D motion, if let's say everything was happening in 1D, then what was the thing? What did we do? We used to have simply v equals to u plus at, which you learned in 9th grade itself. S is equal to ut plus half at square, and v square equals to u square plus twice of as. This is but the moment we change into 2D, we have to now take care of in 1D the advantage was everything was happening in one line, so we really didn't care about the direction part, besides taking care of the negatives or the positive direction and negative direction. But now, since we are now dealing with vector motion in 2 dimension, then we have to use we have to be very cautious and use vector equations only. So if you see, now how do we proceed from here? So let's say if you have to use v is equal to u plus at, v plus at. Let's analyze one equation, and then you will understand how to use the other ones. So let's say as we learned in resolution of vectors, let's use that part. So v can be written as vxi plus vyj. Yeah, this could be v, and u again could be uxi cap plus uyj cap, and similarly a acceleration, a was axi plus ayj. Right? So let us now write, substitute these, equation number 1, equation number 2, equation number 3 in this equation. So let's say equation number 4. Okay. So what do we get? In the LHS, I can write vxi plus vyj is equal to uxi plus uyj plus axti plus aytj. Okay. Now the next step is to collate all x's and y together. So hence I can so I can say vxi plus vyj is equal to ux plus axti plus uy plus aytj. Okay, so if you see now, look at this equation very carefully. Now there is a vector. So on the left hand side there's a vector. This is one vector, and on the other side, on the right hand side also, this is another vector. Another vectors. Now we learned inequality of vectors that if two vectors are equal, let's say, and they are into their resolved form, then what did we learn? We learned that the I component will be equal to the I component and j component will be equal to the j component, because otherwise the equality of the vectors cannot be established. So this is one in x direction. So x direction, x components have to be matched together and y components have to be matched together. So hence we say vx is equal to ux plus axt, and we say vy is equal to uy plus ayt. So matching what? I to I. So let's say this I component to this component. This is I to, and then this j, this part to this part. So if you equate these two, so you'll get these two relation. These two relations. Now, so your work just got doubled, in the sense, in your 1D you had only one equation, v equals to u plus at, and here you have basically now for everything you have to deal with two such equations. So all the two other equations will also get resolved like that. So how? So let me explain. So it will be sx now. Sx will be equal to ux. Sx will be equal to uxt plus half ax t square, and sy will be equal to uyt plus half ay t square, and the third equation will be vx square is equal to ux square plus twice ax sx, and vy square equals uy square plus 2ay sy. These are just, so hence but where we used to see 3 equations in 2D in 1D motion. Now we have 6 equations in 2D motion. So if you are able to, so basically what you need to do is, whenever you are analyzing a 2D motion, you resolve it in 2 parts, all the components, be it position, acceleration, or velocity, and then use the 1D equations in 2 different directions. That is, both the components you apply the 3 equations, and you will get your analysis is done. Let's take an example, and this is where it is mostly used, and that is in the projectile motion. So let us take projectile motion and understand, and then try and use these concepts there. So what I'm trying to go and discuss is, how is projectile move? How does a projectile move? So projectile motion. So you have played Angry Birds, where there is a catapult, and the catapult, and you pull the catapult, and you throw the bird, and this you have also learned elastic potential energy. So this has elastic potential energy, and then when you release it, what happens? This particular projectile goes like that and hits the target. Yeah, so this kind of a motion is a projectile motion. Or when a cricketer hits a 6, cricketer hits a six. He lofts the ball in air. So basically, he strikes the ball. So this was my, from here he hits. This is the stumps, let's say, and then he hits the ball. He hits the ball, and it crosses the boundary line, and you score a six. So let's say this was the boundary line, and the ball goes here. So this is an example of projectile motion. Next time you watch cricket and see Virat Kohli hitting a six, please remember that you are watching a projectile motion. Or when a cannon fires a shell. So, I gave this example in the class also, that during Kargil war, you have to, be very precise. The enemy was sitting at the top of the hill, and you were firing from the ground, or let's say, the foothill. So let's say this was some Tiger Hill or whatever, and then here was the cannon. So some 2-3 kilometers away, or maybe more away, and then the enemy was hiding here, let's say, which was not in the line of sight of our armed forces. So what do? So you change the angle and fire in such a way that the shell goes, and so if you fire like that, it will hit the this end. So you have to change the angle, and let's say the muzzle is in this direction. What will happen? Now the shell will travel this path and then hits the target like that. So this is all, we'll see how, what all parameters. So what did we do? Let's say when you play a Angry Bird game, or when you are, a tank game or whatever. So basically you change the orientation of the gun. So when I say change the orientation, is these are the parameters which are in your control. So you can do what? You can throw at one particular velocity, and you can also, command the direction in which the body is thrown or the shell is thrown. So depending upon that, you can actually control the path of the projectile and achieve your purpose. So let's now understand in a more detailed manner what exactly is this projectile motion, and how do we do calculations around it. Now, if there is any doubt, you guys can just put that thing in the comment section. So this is how, let's say, now let us examine the projectile motion in detail. So again, let me start with our reference point, reference coordinate system. So this is my reference coordinate system. Okay, and what did we do? I am now, let's say this is the projectile which I'm talking about. Okay, now, yeah, so let's say this is the projectile. Projectile is, so it was launched, and it took a, actually this path is called a parabola. So you will learn that the path traced by a horizontal, or a projectile is a parabola. But how? Let me explain. Now, let us say that this is y, this is x. Yeah. In this, we will learn. This is a simple projectile where, so there could be multiple types of projectile. For example, let's say this is an inclined plane, and again a shot was, done like that, taken like that. So this is another type of projectile. We'll learn that as well. But for the simplicity's sake, let's first take up a horizontal projectile in a horizontal plane. Okay, and sorry, so basically the start point and the end point lies in the same horizontal plane, and it's a vertical, or and the projectile is the motion path is in a vertical plane. So how do we analyze such motion? So let's say this body was launched, or projectile angle of projection, projectile angle was this. Let me draw it a little better manner. Okay, so what I'm saying is, let's say this is, so don't get confused by the length of the vector here. I'm just trying to exaggerate the view so that you understand that this is the initial vector. So this is what? Initial vector, and I'm coining the term u, right? So u is what? So I'm writing it here. U is initial vector, initial velocity with which it was launched. At that instant, when it was launched, it was with initial velocity u. Now, let us say the projectile, this angle was theta. So when it was, so the instantaneous velocity at which it was thrown, at that point in time, it was making an angle theta. So these are the terminologies. So let's say it traces this path It traces this path, and let's say this is the maximum height attained by the projectile. Let us say this is h max, highest point. So highest, distance from the ground, what it attains is h max. This particular thing is called range r. What is range? From the initial point to the point it makes the contact with the ground again, this point is called range. Let us say this is point A, this is B, and this is C, and let's say this point is highest point is D. So AB is my range. So what is range? R is equal to range. There's another definition. Let's say T. T is, let's say, time of flight. Time of flight. So what is it? It is nothing but time taken by the projectile to, let's say, from the launch to the point when it hits the ground again. That's time t. So it travels this whole distance in time t. Yeah, this is the actual distance traveled. If you see the curve path, but the displacement is r only. Yeah, so t is time of flight. Okay, now yeah, we got range, we got time, and then we'll also see the max h max. H max is the maximum height attained, right? So max height attained by the projectile. Max height attained. Let me write it a little clearly. So this is max height attained. Okay, now let us try and find out if we can, find r, t, and h max in terms of u and theta, and obviously g. G is what? So if you see all through the motion, there is a constant acceleration due to motion, acceleration due to gravity, which is g acting downwards, and its value is how much? 9.8 meter per second square. Okay, this is throughout the motion, this is happening. Now let us, so hence now let's try and understand how can we analyze this. So basically how we approach it is, again, if you see here, what do we now need to do? We need to resolve all the elements of kinematics or the parameters of kinematics into its x and y component and treat them as if there is only one 1D motion happening. So let's do that. So what all are there? So let's say first of all u. So if you see, u can be broken down into two components, and this is x and this one is y. So u can be easily written as uxi plus uyj. And what is ux and uy? Very clearly, we just learned above that it is u cos theta I plus u sine theta j. Okay, so u is nothing but u cos theta I and u sine theta j, where u cos theta and u sine theta are plane scalar quantities. Okay, now if you see, this is u. Okay, this was the initial velocity. Fair enough. Now what is let's say the total acceleration acting on the body at any given point? So a is clearly 0I, because there is no acceleration in the horizontal direction, and minus gj. Why minus gj? Because the acceleration is always in the negative y. If you see, this one pointed above is positive y, so g is negative, minus g, right? G is going down, so hence we say it's a minus gj. So a is this much. Okay, do we have components for t? No, because t is a scalar quantity. So t is total time taken from a to b, from reaching a to b. Okay, what is vx? And so what is v? V is the final velocity. Now final velocity depends on which time interval you are talking about. Okay, which time interval you are talking about. Now let us say that if let's say r, what I'm trying to say is, let's say total time taken was t in this motion, that is from a to d and from d to b, it takes total t. So there is, without loss of generality, we can say that the time taken for this body to move from this point to this point, that is the half the journey will be covered in time t/2, and the rest half will also be covered in terms of t/2. Let me draw in a different, so that you don't get confused. So what I'm trying to say is the time taken is t for the full motion, but here it's t/2 for this journey, and here also it is t/2. So time taken to go up will be equal to time taken to come down. Yeah, so we learned in 1D motion also, if you let's say throw something up vertically up, the time taken to go up will be equal to time taken to come down, right? So this will be a useful information here. Okay, what else other information if you see? So if you see here at this point, the instantaneous velocity is directed towards the tangent, right? Like that. Now if you see, this is instantaneous velocity, let's say v, I am saying v, v instantaneous. So or let's say v instantaneous, okay, at this point. So what is, if you see, this is totally horizontal. That means there is no component of velocity in the vertical direction. That means here the y component of velocity is 0. That means it is not going up any further. It is the y component of velocity is 0. So from here on, it will start going down. And why is it 0? Because if you see, it is the velocity vector is parallel to the ground. So hence there is no component whatsoever in perpendicular direction. So hence velocity in perpendicular, or let's say vertical direction, is 0 at this point. At this point, d velocity in perpendicular direction is 0, but horizontal direction there is some v. Okay. Now let us analyze the two. Let me just make it a little, yeah, so that it becomes, yeah, we have enough space to work on. Now if you see, I have just reduced the, now we'll analyze. So let's analyze here. Yeah, what is it? We will analyze in two directions. So first will be in x direction, and the other will be in y direction. Y direction. Okay. Now, so in x direction, let us say, what is ux? Ux was nothing but, we saw u cos theta. What is the time taken total is t from a to b. Time to a to b is t. Yeah. And then what else is there? Ux is there, t is there. Then is ax there? Ax is 0. Ax is 0 from here. If you see 0 I, so there is no acceleration in the x direction. So hence vx will always be, we know vx equals to ux plus at. Since a is 0, then we get what? Vx is always equal to ux. Vx is always equal to ux. That means what? If you see this instantaneous velocity, any time, any given time, the x component of the velocity is same as the initial x component of the velocity. So here, if you see v instantaneous at this point is same as the x component of u, that is u cos theta. So hence I can say this is u cos theta all the time. So the x component of velocity is u cos theta all the time. For example, let's say if at this point the body was moving like that. Now if you break down into the two components, so the two components will be this and this. Now this particular component is nothing but u cos theta all the time. U cos theta. This particular component will be u cos theta. So anywhere you take, let's say if you take here also, let's say you are trying to find out the velocity here, and then you take the components, so this and this, oh, this is again u cos theta. So every time the x component will be u cos theta. That is what is understood by this. Okay, fair enough. Now, so clearly, what do I know? So r will be nothing but ux into t, because there is no acceleration. This is one. Acha. Now here let's analyze this. So in y direction, uy was u sine theta. Clearly. T, now let's say a to d, when this guy goes a to d, from a to d means from, let's say the vertical height attained is h max, right? But then motion is happening from a to d, but time taken is nothing but t/2. So time taken for this body to reach the max maximum point is half of the total time taken, so t by 2. Ay was clearly minus g, and at v y d, that means the velocity, the y component of the velocity at d is 0 because it is moving horizontally, so the y component is 0. So now you can find out time of flight from here. How? So we know vy at d is nothing but uy minus g into t by 2. Yeah, we use the first equation, v equals to u plus at. Uy I know, g was negative, always downwards, it was pulling it down, and time taken was the total time, t was the total time of flight. So the time taken for the body to go from a to d will be t by 2. So now moving ahead, if you see, this is 0 equals uy was u sine theta and minus g t upon 2. So from here, what do I get? This implies t is equal to 2u sine theta upon g. That's something called time of flight. So we got t equals to, this is one relationship, t equals to 2u sine theta by g. This is very, so whenever you see a, projectile motion like that with no complications whatsoever, so you now know t is equal to 2u sine theta by g. So, but then I would advise not to, you please remember the formula, but not use it blindly. You judge the case, and depending upon the merits of the case, you apply or not apply this formula. But yeah, for all objective type questions, you can obviously, must remember the formula, so that, yeah. But the caution is, please make sure what are the assumption under which we derived this, and then only you apply. For example, if you try to apply this formula here in an inclined plane projectile, it might not work. So it will not work in all certainty. So you have to change a lot of stuff over there, because there is one angle of projection, there is another angle to the wedge, and other parameters. So hence, you please take care of that. Now, so time of flight is known. This t was the total time taken, right? Now what? We can clearly find out range from here. So what was range? Range was this. So let's use this particular equation, time of flight in range. So what is range? I'm doing it here. So range becomes ux into t, which is nothing but u cos theta into t. And what was t? T was from this equation 2u sine theta by g. So simplifying, what do I get? 2u square sine theta cos theta upon g, right? Simplifying further, you can simplify this as u square sine 2 sine theta cos theta upon g. Now in trigonometry we know, what do I know? I know 2 sine theta cos of theta is nothing but sine of 2 theta. 2 theta in trigonometry we have learned this. So hence this particular equation becomes u square by g sine 2 theta. So hence this is my range. So second equation which I got is r is equal to u square by g sine 2 theta. Okay, now one thing which is remaining. So what all did we find out? We found out, and what was objective? Objective was to find out. So we found out this. Let's find out h max. What's h max? The maximum height attained. So we obviously h max will be, for finding out h max, we will consider y direction motion. So let's do it. So let's further it. And what do we do? So let me say that, okay, so here I am. So we are continuing with the y direction motion in this segment. Okay, now so h max. So this is, now let me simplify this. So the case is simply like this. So there was a body which was thrown up, and it went to the maximum. This attained maximum height. Let's say this is h max. This is the case now. So the initial velocity was uy. uy, and it took how much time? T by 2. T is the total time of flight, so it took T by 2 to reach here. To get what? Vy is 0, 0, 0. So we can use the second equation of kinematics, and we can say that H max in this case, H max is nothing but ut. So u what t? Uyt, y direction initial velocity, and t was nothing but T by 2. It's not the complete T. This is T by 2. T by 2, why? Because T is the time of flight, and it takes only half the time of flight to reach at the maximum height. So u T by 2, and then minus half g T by 2 whole square. And why am I writing minus? Because the acceleration is against the motion, so hence negative. And T by 2 again, because only half the time of flight was required. Let's simplify. What do we get? Uy was u sine theta, and t was from this equation we can find from here. What is t? T by 2 basically. So T by 2, if you see, it's nothing but u again, u sine theta by g. T by 2 from here is u sine theta by g. Then minus half, let me just segregate this image out. Okay, yeah, minus half g into t square by 4. This is t square by 4, or T by 2 whole square. If you see from here, I'm just writing here as a separate this thing. So this implies T by 2 is u sine theta by g. That's what we used. And if you square it, you will get, what will you get? You will get u square sine square theta by g square, sorry. Right? So if you see, this 1g will get cancelled from here. Now what do I see? I see u square sine square theta by g minus u square sine square theta upon twice of g. So which is nothing but u square sine square theta by 2g. If you simplify this, then what do we get? So I'm summarizing. So these three things we got. Summary. So what do we get from here? This analysis. We got time of flight t is equal to 2u sine theta upon g from here. If you see here, 2u sine theta by g. Then what else did we get? We got r equals u square sine 2 theta upon g. And we also got H max is equal to u square sine square theta, u square sine square theta by twice g. So this is the information around, let's say, my projectile motion. So please remember this. One more analysis. If you see, let's say, for this is the thing, for a given u, what should be the angle of projection, or let's say projectile angle, whichever way you want to call it. The angle of launch, I say, let's say angle of projection, so that r is maximum. Yeah, we can either use our concepts of calculus, or you don't even need to use a concept of calculus to find out. Let us first analyze r. So if you see r, the relationship was u square sine 2 theta upon g. Let's analyze that. This is r. Now why are we talking about this particular case? Let's say, again, going back to this, let's say you are at war, Kargil war. What is happening? Let's say there is a capability of the gun to to launch a particular shell. That depends on the design, the design parameters and many other things. So you really cannot go beyond a point in terms of the initial velocity of the launch. So for example, when the when the gun is pointed like that, you really cannot work beyond a point. You can basically reduce the velocity maybe, but you cannot increase the velocity of the launch beyond a point. Let's say there's a shell which is going to be launched like that. So U is kind of fixed. The technology, there's a constraint, so U cannot be changed beyond a point. But can we do something so that the shell reaches the largest point or largest distance? So if you see very intuitively, if you have this particular muzzle pointing towards the sky, so what will happen if it was pointing towards the sky? So the best it could do is it will explode itself, right? It will go up and come back, and then there will be explosion, and the entire gun will be lost. So here what do we say? R is 0. And as you keep on tilting, or as you keep on reducing the angle made, so here what is the angle made by the ground? This is 90 degrees, isn't it? In case of vertical launch, 90 degrees. If you see, if you start tilting it towards the ground, then what will happen? There will be the ranges will be more. The ranges will be more, right? And there will be so hence in this case it is shooting like that. Then let's say if it was in this direction, then it would have gone and then on like that. So hence there will be multiple such cases. The question here is, what should be the optimal value of this theta? What theta I'm talking about? This theta. Right? So what should be the angle of projection? This theta, so that without changing anything, I get the maximum range. Maximum range. So let's analyze this here. So if you see, R is equal to U square sine square theta. You really cannot touch U. We told you that this depends on the design parameters, and there's a point beyond which you cannot touch it. Really, you don't have any control over Mother Earth. So, and you are located at one particular position. You cannot really go up and down and even beneath the Earth's surface. So G is fixed. U square is fixed at one particular point. So the only thing which is under your control is angle theta. Okay, and we know that for R to be maximum, or let me use the same color, for R to be maximum, U square sine square theta should be maximum. U square sine 2 theta by t should be maximum. Should be maximum. U square and G. So only thing. So hence sine 2 theta should be maximum. Should be maximum. Now, what is the maximum value attained by sine 2 theta? So so maximum value sine 2 theta can attain is, so hence sine 2 theta must be equal to 1, because sine value remains confined between -1 and 1. That means, and when is this possible? That means 2 theta must be equal to pi by 2 or 90 degrees. 90 degrees. 90 degrees. That means what? Theta must be equal to pi by 4 or 45 degrees. So what do we learn? So if we launch at 45 degrees angle from the ground without doing anything, you will attain the maximum range of the projectile. Okay. Now let's quickly go to the let's say the projectile on an inclined plane. Okay, let me cover that. So hence, let's say you had a inclined plane. Okay, let me just draw a little bit more. Yeah, so this is the inclined plane, and you launch you have this motion. Okay, so in such cases, what do we need to do is, so let's say this angle from the inclined plane was theta. This was the angle of with reference to the inclined plane, and the inclined plane itself is an angle, let's say alpha, with the horizontal. So what in such cases, what do we do is we rotate our coordinate axis as well. So let's say along the incline is x, and perpendicular to the incline is y. This is my definition of coordinate system. So what will happen in this case now? If you see, so hence everything will, so all the things will change. How? So let's say this was u, this is u. Okay, so basically now if we will resolve the every vector in two components. So this is, let's say in this reference frame, this is ui and this is ux, correct? So hence, how will you analyze now? So you will again take the two directions separately. Let's say x direction. So x in terms of whatever x and y you have defined, and then y direction. Now if you see what is ux, ux is nothing but, if this was u, it's u sine theta, u cos theta, sorry, u cos theta. So if you see this is u, this one is u, and this angle is theta. So ux will be u cos theta. It contains the theta, so cos component, and uy will be clearly u sine theta. So you now know uy, u sine theta. So far so good. It looks similar to the previous case, but the only difference here it will be that now g, let's say g was acting in this direction. This is g, but then we have to resolve g in along the x and along y. So g can be resolved along x like that and along y like that. And then if you see, if this, so this angle will be 90 minus theta. So this angle is theta again. This angle is 90 minus theta. If you can do the calculations, this angle will be my 90 minus theta. So this is theta. So hence this is g cos theta, and this is g sine theta. G sine theta. Containing theta has cos, not containing theta is sine. So if you see, so t again, you can take t as t by 2. Tx is t by 2, and ty will equal to tx equals to t by 2. Same time, ax will be what? Ax, if you see, ax is minus g sine theta. Minus g sine theta. Why? Because it is in the negative x direction. If you see, it's pointing away from positive x. And ay similarly will be minus g cos theta. Why? Again, pointing away from positive x-axis. Yeah. Okay, here what else? Here it will be r again, range. So let's say this was the range r, rx. Yeah, so hence I say sx is equal to r. And here for the total motion, sy is 0. For the entire motion from point A to point B, there is no displacement in y direction, so sy is 0. Now, depending upon which two time frames, your time windows you are operating, sy will change. For example, if you are taking this time frame, then you know, so basically whatever is a so you have to be careful. You know, we have to find out whether time x is t by 2 in this case or not. Yeah, so because this is not symmetric in terms of, or as symmetric as the previous problem, so hence there is a question mark. You cannot really write like that. You have to evaluate first, because this is, even if it is same, it is not intuitive here. So you'll have to find out what is txn. So you cannot write this. Okay, so tx and ty now becomes variable, and you have to play with whatever information you have. What information do you have? You have an information that this is alpha, the angle of the inclined plane, and the other information you have is, you know, the final displacement in the entire motion. It is 0, right? And with this information, you'll have to play around with the three equations which is given, and then use geometry and the knowledge of vectors to resolve or to find out all the variables which are asked in the question. So this is how you have to. So don't mug up the formula for every such case. Yes, it is always a good practice to remember them, but before you even deploy, please be cautious that all the assumptions and the scenarios for which that formula was meant is being met. If the assumptions and conditions are being met, then only you go ahead and deploy the formula. So what did we learn in 2D motion? In 2D motion, if you're good at vector equations, you will never make a mistake. So there are only two. So if in the nutshell, if I have to just write down the basic concepts working around, is simply this. One is velocity is ds by dt. This is equation number 1, which you must do. First derivative of position, the rate of change of position vector is velocity, and acceleration is dv by dt, right? Because these two equations only gave us which two equations, which three equations? These two differential equations were responsible for giving us these three kinematics equations: v equals u plus AT. Again, note the use of vector notations. S is equal to UT plus half a t square, and then V square is equal to U square plus twice a S. And then what did we do? We actually resolved, we had component equations, Vx, Vy, Sx, Xy, and again Vx, Vy, and parallelly, other stuff as well were broken down into components, isn't it? And then depending upon the merit of the case, we use these equations, we treat X and Y independently, and we use the conditions given in the question to find out the required information or the data asked for. And beyond this, actually there is no other concept which is deployed. So all this analysis of projectile, all these three equations which we just got was nothing but application of these three vector equations only, so in two different components. So now you can extrapolate this information. How? So if this works in 2D, the same thing will work on 3D as well. So in that case, what will happen? Simply V will be replaced by Vxi plus Vyj plus Vzk. So there will be three components. Similarly, S will be resolved into three components, U will be resolved in three components, and A will be resolved in three components, and we'll write three vector equations again. So for each vector equation, there will be three component equation. So in total, we'll be getting 9 component equations, and using that, this basic concept will be used to do it with, and this basic concept will be used to deal with 3D vectors as well. Okay, do you guys have any questions here? Please shoot the question in comments. Maybe if what you can do is either you can post it on the group or on the comment section. What we'll do is we'll come up with a solution maybe in a different video. We'll shoot it and post it as a response to this. But now I hope I made the 2D motion clear to you. Now you can solve questions. The ideal advice would be you solve the textbook questions first. If you get stuck, you can always put a comment here itself that, okay, question number this in NCERT or in H.C. Verma or any other XYZ book you are following, you got stuck. And then our team, they'll do is they will pick up the question, the comment from that comment section, and what our aim is to come up with a full video around the solution, and we'll post it there. Projection starting from a height. Yes, Vijishnu. Let's do this. So very good question. Jishnu is asking, how do we deal with projection from a height? Let me show you that. So, okay. So now, the question is projection from a height. So there could be two ways to deal with, or not, basically two examples, projection from a height. From a height. What is it? Let's say, again, no need to do much of a, or usually make it complex. So let's say this is the case. And there could be two examples. One is, let's say the projection was done horizontally. So like that, it goes and falls. This is one case. Another case could be that from here itself, it was given an angle of projection and then it goes like that. These could be the cases. Something like that. Okay. Now, how does our, the analysis change? It remains absolutely same. What you need to do is, let's take the blue one. Let's say this was the first case where it was thrown horizontally. Okay. Let us say this is U, and hence theta becomes 0. And let us say this is H, or let's say S, Y. Okay. So what will change? So again, you have to do what? The usual practice. This is a very good practice. Let's say X. Write down all the parameters along X-axis and Y-axis. So if you see, Ux is simply U, because there was no vertical component. The entire velocity was in the horizontal component. Ux is U. Is there any Ax? No. There is no acceleration in horizontal direction. Okay, time, you can assume whatever time window you want. For time, you have to find out the initial. Let's say if this was the initial and this is final, so TAB, let's say, is T. And if you see what if you are taking, now it depends on where are you taking the origin. So if your origin was here, if you have taken origin at O, then was there any initial displacement from the origin in x-axis? No. So initial displacement SIX, or the other way around, let's say SXI initial is 0. Okay, and what else? So now V will depend on which point you want to calculate the V. Other given information here, Uy will be clearly 0 because there is no vertical component. Ay will be clearly minus G. Why? Because there is a acceleration due to gravity always. Now in other cases, in higher ups, what they can do is, let's say they will throw a charge in an electric field or a magnetic field, things like that. So plain and simple, let's say if let's say electric field, this is a unit charge, or let's say some charge on this particle, and electric field exists like that. And if this was a positive charge, so hence again this electric field E will try to deviate it. So not only G, you will have to consider E also. Okay, in that case. So hence in that case, you'll have to find out the acceleration due to E as well as acceleration due to gravity both. So whatever forces are acting, you'll have to use the acceleration accordingly. So in this case, let's say there was no E, nothing, no electrostatic forces acting. So let's say only gravity is acting. So Ay is minus G. Clear? Now time taken for the body to go from, let's say, here to here. So time in any two given points, let's say it is P and it is Q. Now let's say if you are analyzing only this motion, so time taken by the body to go from P to Q is, so in if you break the journey into two components, so the x component of the journey, that means the time taken by the body to reach point Q to, let's say, P dash, is same as time taken by the body to reach from, let's say, P dash to Q. You have to understand this. X component time and Y component time. There is no component of time actually. But what I'm trying to say is the displacement in X direction and displacement in Y direction, in that in two given points remain, the time taken remains the same. Okay, so you have to consider those two times, and then what else? So these are the vital information, and so in this case there is an initial Y, and let's say if your origin was here, so initial Y was Sy. Okay, so how will the equation change? Equation will change like this. So hence, if you see the second equation, let's see where S is involved. So in second equation, we usually write what? S is equal to UYT plus, or Sy is equal to UYT plus half AY T square. This is the second equation. Now, if you remember how we derived Sy was nothing but the displacement in time t. Okay, Sy was nothing but, Sy symbolized what? Displacement in time t. So in this case, if you're considering a motion between A and B, so what is the displacement? Actually, the displacement is Sy itself. So you have a displacement of, isn't it? So how do I find out the displacement in time t? Is nothing but the final position of point B. So if you nothing but how far it is from x-axis, 0. The final position was 0 and initial was Sy. So this becomes my displacement in time t, and then you can write Uyt. So Uy was 0. So 0 t minus half Ay is G, and then it is T square. So from here, what will you get? You will get Sy is equal to half G T square, and hence you'll get T equals 2 Sy by G under root. Yeah. So from here, when you got the time taken for the body to travel from A to B, now you can, you know that, what is R? What is R here? So R is nothing but Ux into time t, because there is no acceleration in this side. Yeah. So hence, ideally there has to be plus half Ax t square, but this item is 0. Why? Because Ax itself is 0. Yeah. So hence it is reduced to Uxt only. Yeah, so now you can find out R is nothing but T times ux. Ux is u cos theta, u cos theta. There is no theta here, so ux was u from here if you see. So you'll simply write u into T is 2sy yg. So whatever is sy, you find that out. You can find out R. So this is how, on the merit of the question, you'll have to now, if the second case, which is, let's say now, the second case is where u is in this direction. Then again, what will change? In this case, now the change only will be ux will become u cos. So let's say this angle was theta, so ux will become u cos theta, and uy becomes u sin theta. Simple, instead of 0. So here you cannot write now in u 0 t, so it will give you a quadratic equation, and you'll get t accordingly. Then deploy t over here, whatever t you will get from this part. Did you understand? I'm repeating once again. So in the second case, it will no longer be 0. It will be u sine theta. Now the moment it is u sine theta, use it here, u sine theta t, right? So you'll get a quadratic in t. Solve the quadratic equation. You will get the value of t in terms of sy, g, and theta. Deploy that value of t here in this equation. Multiplied by, instead of u here, it will be u cos theta, because ux will also change, and you'll get R accordingly. So depending upon the merit of the case, you have to change this. So hence, if you see, I didn't deploy any formula from my memory. I again did what? I broke down the entire problem into x and y components. All the kinematic elements like acceleration, velocity, position, vector, everything was broken down into x and y component. The x component is treated separately from y component, and the information in one is used to calculate the variables into the other. That's how the entire projectile motion problems and 2D problems will be solved. So I think we are overshooting the time here. I have a follow-up class now. So Shreyas, we will take up a circular motion once again. We'll set up another such session where. So do like the video if you found it interesting, and post your comments and post your queries in the comment section, because after this video also we will be going through your comments and we'll pick up the questions from there and try to come up with a follow-up video on that. So do put your comments over there. Okay, so I hope the session was useful for you guys, and let's meet again as we have planned. We'll meet again on Wednesday evening. And the better way of doing it is if you have specific queries, which you can send it beforehand to me, so that our class would be more focused and pointed. So thanks a lot for all of you for joining this session, and do like the video and motivate us by subscribing to this video, and help us reach out to many more people who are in requirement of such assistance. Thanks a lot and have a nice day. Bye.